Bismillahirrahmanirrahim. Dear students, welcome you all to the Industry of Pharmacy class. And today lecture you start the new chapter, that is evaporation. In this lecture we will discuss in detail about the evaporation, recalling from one of the previous class in which we have discussed the difference between the drying and the evaporation. We have to elaborate the evaporation process in this discussion, and we will discuss the general principles of evaporation, various types of evaporators, and evaporation under reduced pressure. Dear students, the main objectives of today's discussion is to learn about the basic principles of evaporation process and the various types of evaporators and evaporation under reduced pressure. After the completion of this lecture, you will be learn about the general principle of evaporation process, evaporators, and the final part of the lecture we will discuss evaporation under reduced pressure. First of all, we will discuss the general principles regarding the evaporation. Evaporation is basically process of removal of solvent from the solution. And how to remove the solvent from the solution? By the process of boiling the liquid in a suitable vessel or container and withdrawing the vapor. If we withdraw the vapors of the solvents, and by this way concentrated product will be resulted. So evaporation is a process of removal of the solvent from the solution. But here the boiling of liquid is processed in a suitable container and the vapors are withdrawn and leaving a concentrated product. The evaporation process is used in the manufacture of blood drug, particularly, and the pharmaceutical industry. Mostly the plant origin extracts are concentrated by removing the solvents using the rotary evaporator, and the active pharmaceutical ingredients are concentrated in the form of the concentrated product. Thus, a practical definition of evaporation process is the removal of liquid from a solution by boiling the solution in a suitable vessel or container and withdrawing the vapor, leaving a concentrated liquid residue. And the liquid residue that is concentrated, that is the ultimate product when we remove the liquid from the solution by boiling the solution, which is kept in a suitable container or vessel. This means that heat will be necessary to provide the latent heat of evaporation or vaporization, which we have discussed in the chapter of the heat transfer. That's what is meant by the latent heat of vaporization. That is the amount of energy to convert into the vapor state from the liquid state, and that amount of energy is termed as latent heat of vaporization. In general, The rate of evaporation process is controlled by the rate of heat transfer. Now we will discuss the mechanism of evaporation. When heat is supplied and the solution, the movement of molecules increases, and molecules present in the surface overcome the surface tension of the liquid. If we increase, if we heat up the liquid, and it evaporates because surface molecules have less cohesive force than others. It is due to the application of heat and solution, which ultimately increases the movement of molecules. Now, in this part of the chapter, we will discuss the various factors affecting the evaporation. There are several factors to affect the process of evaporation, including temperature, surface area, agitation, atmospheric aqueous vapor pressure, atmospheric pressure on the liquid under evaporation, type of product required, and economic factors. These are some of the prominent factors which affect the process of evaporation. Before going to discuss the different types of evaporators, there are some basic parts of which is included. One of the basic part composition of evaporators include the heat exchanger, vacuum, vapor separator, and condenser. These are the basic parts of the evaporators, and which the process of evaporation will be take place. What is meant by evaporators? Evaporators are a device used to turn the liquid form of a chemical into its gaseous form or vapor form. The liquid is evaporated or vaporized into the gaseous state, and thereby the product is concentrated. And many types of evaporators and many variation and processing techniques have been developed to various products, depend upon the types of product to be achieved. Various types of evaporators are developed for the processing. Now, this is the classification of types of evaporators. There are three categories, including a natural circulation evaporator, forced circulation evaporator, and film evaporators. And the subtypes in the natural circulation evaporators, which depend upon the natural circulation process, including the evaporation, evaporating ponds, evaporating still, short tube evaporators. And the second class is forced circulation evaporator, the application of force, and film evaporators, including climbing film evaporators and horizontal film evaporators. These are types of the evaporators. One of the class of the natural circulation evaporator example is evaporating pond. You can see in the figure that is air ventilation system and steam entry system over here are the walls, and there is a jacket and condensate outlet and product outlet at the bottom. And the evaporating pan consists of a hemispherical shallow that is made up of copper, stainless steel, or aluminium. That is the composition or construction material of the evaporating pan, and this is the hemispherical shape. Now, how working of this piece of equipment that is termed as evaporating pan. Aqueous extract is placed into evaporating pan. Steam is supplied through inlet. Here we kept the aqueous extract, and then the steam is supplied to this entry. That is the steam inlet. Steam gives out heat to the contents which we have kept or placed in the evaporating pan, and the condensate leaves through the outlet. The content, that is the aqueous extract which we have placed in the evaporating pan, must be stirred manually for small volumes and mechanically for large volume. We can manually stirring process can be done for the small volume content, but in case of the quantity is larger and volume, then mechanical shaking is done for the contents. That type of operation is fast at initial stage and decreases gradually as the liquid gets concentrated. When the liquid becomes concentrated, then the rate of operation will become slower because the latent heat of evaporation, which causes the formation of vapors, will be minimized because of the small quantity of the liquid film to be evaporated, which we have discussed in the heat transfer chapter as well. Room where evaporation is carried must be fully ventilated, otherwise the room is quickly filled with the fog of concentrated wet vapor, and water falls from the roof and run down the walls. That's why we have to uh, set the fully ventilation of the room, because if we have no proper ventilation system, then in this case the room will be filled abruptly with the fog of condensed vapors which is formed, and water falls from the roof and run down the walls of that particular room. So the ventilation system should be properly managed and should be carried out. Fans fitted over pan remove vapor, prevent concentration in room, and accelerate the rate of evaporation by quickly removing saturated air from the surface of the liquid. For this purpose, in order to remove the condensation in the room, fans are fitted over fan to remove the vapor form. This is our evaporator fan. Concentration of aqueous and thermostable liquids. It is used for concentration of aqueous products and the thermostable liquids. And for liquid extract containing water as a menstruum, for example, liquid extract of liquid ice. And there are certain advantages of the evaporating fan. That is for used for both large and small scales, simple in construction and easy to operate, clean and maintain. Due to these advantages, evaporating fan is selected for the process of evaporation. Cost of installation and maintenance is low compared to the other piece of equipment. Construction with wide variety of materials that I have told you about, the construction material like the copper, aluminum, and stainless steel. These are available and widely used for the construction of operating fan. Stirring and removal of the product is easy in case of small as well as in case of large volume that I have told you in the earlier slides. There are certain disadvantages of the evaporating fan, including heat economy is less. so cost per unit material production is more. And secondly, it is not appropriate for heat sensitive material because we have to heat up the material due to long time of exposure. The material are exposed to heat, and that's why it is not appropriate for heat sensitive material. Heating area decreases as the product gets more concentrated, and that's why the rate of evaporation decreases when the product becomes concentrating. And the third disadvantage is that it is open type of equipment because we have to put the material which is to be concentrated, and so vapor passes into the atmosphere, which can lead to saturation of the atmosphere. That I have told you that about the proper ventilation of the room should be done, otherwise the vapors will be circulated in the room and slowing evaporation as well as causing discomfort in the atmosphere. In case of room, that I told you, proper ventilation should be done by fan installing, that is fans fitted over pans remove vapor to preventing the condensation in the room. That is one of the example of the environment in case of room. It creating problem slowing the evaporation process as well as causing the discomfort. Boiling point of water cannot be reduced. It is another drawback. So reduced pressure cannot be created in open type of evaporator because it is open in nature, and an open type of evaporator, it is not possible to reduce the pressure, and ultimately the boiling point of water cannot be reduced in this open type of the evaporator, that is evaporating fan. In this part of the lecture, we will discuss evaporation under reduced pressure. The application of this method, that is evaporation under reduced pressure, is based on the principle that the vapor pressure exerted by a liquid depends on the atmosphere, and the liquid boils when the vapor pressure is equal to the pressure of the surrounding atmosphere. In this case, when these become equal to one another, it is the vapor pressure of the liquid become equal to the pressure of the surrounding atmosphere, then the liquid boils. If therefore the pressure is in the evaporator is reduced below atmospheric pressure, then in this case the aqueous liquid will boil at a lower temperature than 100 degrees centigrade. At normal atmospheric condition, the liquid, that is water, will boil, that is the aqueous liquid, at 100 degrees centigrade. If we reduce the pressure, in this case, when we reduce the vapor pressure, then the temperature for boiling the liquid will be reduced, because I have told you that the liquid will start to boil when the vapor pressure is equal to the vapor pressure of the surrounding atmosphere. The extent of reduction of boiling point of water can be obtained from steam table as shown below, that is shown pressure and reduction in the pressure. If you reduce the pressure from 1 to 0.7, then the boiling point of water will be reduced from 100 degrees centigrade to 90 degrees centigrade. you can see on the screen that the pressure, if we reduce the pressure from 1 to zero point 0.7, then the boiling point is reduced from 100 degrees centigrade to 90 degrees centigrade. If further reduce the pressure from 0.7 to 0.47, then further 10 degree centigrade reduction and the boiling point of water will be occur. Similarly, further reduction to up to 0.31 and 0.12, further reducing the boiling point of water 10 degrees centigrade, and as well as when we reduce up to 0.12 from 0.31 bar, the pressure is reduced, then 20 degrees centigrade reduction in the boiling points will be occur of water, and the water will boil at this stage. When the 0.12 pressure was is kept at 50 degrees centigrade, the water will start to boil. And similarly, if we reduce further from 0.1 to 0.07 and up to 0.03 bar, then the boiling point of water will become equal to 25 degrees centigrade. And this is due to the reduction in the pressure. It's a reduced pressure, the boiling point of water will be reduced. And similarly, the viscosity of water, at chart you can see that is 0.28, and that is increasing by reducing the pressure, as well as the boiling point will be reduced. So in case of the 1 bar pressure, and the boiling point will be 100, and the viscosity of water and Newton second per meter square multiplied by 10 to the power minus 3 will become equal to 0.28, and that will further increases when the boiling point of water is decreased 10 degrees centigrade after the reduction in the pressure. And this is the table. When we reduce the pressure, then the boiling point of water will be reduced. And similarly, the viscosity of water will be increased. Consideration of the data and the steam table that is shown, that I have explained in detail about the pressure reduction and the effect of pressure reduction on the boiling point of water, as well as the viscosity of water, show that the use of reduced pressure has 3 advantages. If you reduce the pressure, evaporation occurs at a lower temperature with less risk of damage to heat sensitive material. So it is one of the way to reduce the temperature, and to reduce the temperature means we have the less risk of the damaging to the thermosensitive material. A lower operating temperature gives higher temperature gradients without the need for excessive steam pressure. And the third advantage is that the lower the operating temperature, the lower the steam pressure that can be used. If we lower the operating temperature, then the steam pressure is also reduced, and it can be used in the steam pressure reduction as well as the lower operating temperature. Now, application of the evaporation. Evaporation is one of the most important processes in the manufacture of pharmaceutical products. Some of the products for which the process of evaporation is applied, including that it is used in the preparation of liquid extract, soft extract, and dry extracts, because we have to concentrate the products. And in case of liquid extract and soft extract and dry extract, which is used, the process of the evaporation will be applied. Then the concentration of blood plasma and serum. If we have to concentrate the blood plasma and serum, in this case the evaporation process is applied. It is also used in the manufacture of drug containing antibiotics, enzymes, hormones, and many other substances. And this is it is also applied. These are some of the applications of the evaporation. Finally, the references. You can consult the practice of industrial pharmacy 3rd edition, as well as Cooper and Gordon Tutorial Pharmacy 6th edition as well. Now overview over the today topic, that what we have discussed in the today lecture. Today we have discussed a new chapter, that is entitled as Evaporation. First of all, we have defined the process of evaporation, that what is meant by evaporation process and what is the aim, and it is used in the manufacture of bird drug, particularly in the pharmaceutical industries. And the heat is necessary to remove the liquid from the solution by providing the heat in the form of the latent heat of evaporation or evaporation, and the heat supply, the rate of heat transfer that is related to the rate of evaporation, the mechanism behind the process of evaporation. That's what will happen when we supply heat to the solution. The moment of molecule will be increased and the process of liquid evaporation will be favored, because surface molecules have less cohesive force than other, and factors affecting the evaporation, the several factors which affect the process of evaporation. The basic parts of the evaporators including heat exchanger, vacuum, vapor separator and condenser. And what is evaporator, and the types of evaporators, variation techniques for the development and used for the various products, and the basis of the product, the evaporators and type of evaporators will be selected. The types of evaporators are three main classes, including natural circulation evaporators, forced circulation evaporators, and fill evaporators. And we have discussed in detail about the evaporating fan, the principle and the material of construction, that is copper, stainless steel or aluminium, and the working, and how the material is placed in the operating pan, and then heat is supplied and then converted into steam through the inlet, and then steam is provided or supplied through the inlet, and the steam is responsible for giving out heat to the contents and the evaporating pan, and the condensate formed will lose through the outlet, and manual stirring as well as mechanical stirring for the small volume and as well as the large volume contents. And the process of evaporation is fast initially, decreases gradually as the liquid gets concentrated, and the room should be ventilated, and not ventilated, then what will be the effects we have discussed. And the fans for this purpose fitted over the fan for removal of vapor, preventing the condensation in case of it is circulated in the room, and accelerate the rate of evaporation. And fans are fitted over fan for this purpose. and then we have discussed the uses of evaporating fan, advantages of evaporating fan, disadvantages, and finally we have discussed the operation under reduced pressure, and if we reduce the pressure, then what will be the effect on the boiling point. We have explained and detailed the extent of reduction of boiling point of water that can be obtained by using this is one of the table regarding the reduction in the pressure and the effect of the boiling point of water reduction on that particular. If you reduce the pressure, then the boiling point will be reduced for the water, and similarly the viscosity will be increases when we reduce the pressure, and the boiling point of water will be decreases. And the consideration of the data in the table showing that three advantages we have explained in detail by using evaporation under reduced pressure. And finally, applications of evaporation that is used for the manufacture of pharmaceutical products, like in the preparation of liquid extracts, soft extracts, and dry extracts. Similarly, it can be applied to concentrate blood plasma and serum, and it is also employed in the manufacture of drug containing antibiotics, enzymes, hormones, and many other substances as well. Thank you all for your attention.